Another numerical methods we gonna to learn is Newton-Raphson method, which used to find the approximation root of a function, especially non-linear function. Some conditions must be consideration when we use the Newton-Raphson method to solving the root finding problem. The first, the nonlinear curve must continuous and it is a differentiable function. When we start the calculation, a good initial guess have to determine what is Newton-Raphson method. How to prove the Newton-Raphson formula? First, let's say we have a nonlinear curve pass through the x-axis, which we call it x-intercept. Therefore, we can make a conclusion that the nonlinear function has a root in between a closed interval of x. Draw a straight line which is the tangent of the curve at the point x known and f of x known or equal to y. As we know, the gradient of the slope also equal to the tangent theta. So tangent theta equal to f of x over delta x or change of x. And tangent x also equal to f prime x equal to f of x over x known minus x1. We rearrange the equation, now become x1 equal to x known minus f of x over f prime x. Then we do the calculation for x1, x2. There is an approximation of the root. The second approximation is better than the first one. So we can do the conclusion. The formula of Newton-Raphson is xn plus 1 equal to xn minus f of xn over f prime xn. We gonna determine the root of a function by using Newton-Raphson method. Now we use the simple function, linear function x squared minus 4 to determine how close the approximation root from Newton-Raphson method compared with the algebraic techniques. So for the function f of x equal to x squared minus 4, we let the f of x equal to 0, then x squared minus 4 equal to 0. We have the x equal to plus and minus 2. We obtain a positive root plus 2 and negative root minus negative 2. The working solution of Newton-Raphson method, given f of x equal to x squared minus 4. So we do the differentiate the function with respect to x. We obtain f prime x equal to 2x. We want to show that the root of the function given is equal to 2. So we let the initial value of x equal to 3. So we let x non equal to 3. Then we apply the Newton-Raphson formula. Xn plus 1 equal to xn minus f of xn over f prime xn. So when n equal to 0, so we have the initial value equal to 3. For the following calculation, we substitute the x non equal to 3 into the Newton-Raphson method. So we obtain the x1 equal to 2.16667. We do the same process of calculation until we get the x4 equal to 2. So we can do conclusion that the Newton-Raphson method can give a better approximation root of a function. We try to solve the problem with a non-linear function. There is x to the power 3 minus 15 x squared plus 300 equal to 0. So first step, we try to obtain a good initial guess. So we apply the intermediate value theorem to solve. So first we let the f of x equal to x to the power 3 minus 15 x squared plus 300. So we try x equal to 5. We get the answer equal to 50. So it's greater than 0 at the positive sign. So we try the other x value, x equal to 6. So our f of 6 equal to negative 24. So it's less than 0, it's at the negative sign. So we can do conclusion that f of 5 and f of 6 have different signs. So f is a continuous function. Therefore, there is a root between 5 and 6. Second part, we need to do differentiate the function with respect to x. We obtain f prime x equal to 3x squared minus 30x. The following step of solution, we have to apply the Newton-Raphson method to find the approximation root of the function f of x. So we have the f of x equal to x to the power 3 minus 15 x squared plus 300. After do the differentiate with respect to x, we have the f prime x equal to 3x squared minus 30x. So as we know, they have the root in between 5 and 6. So we let the x known equal to 5.5. You can let the x known equal to 5 or 6 also can. So we apply the Newton-Raphson method formula. Xn plus 1 equal to Sm minus f of Sn over f prime Xn. So when x equal to 0, so we get S1 equal to, then we substitute the x known equal to 5.5 into the equation. We obtain the x1 equal to 5.6700. We continue with the same process of calculation. We obtain x2 equal to 5.6707. We do the same process until we get the x3 equal to, or x4 equal to 5.6707. So the answer of the root is 5.671 for 3 decimal place. Exercise. Try to solve the exercise yourself. Question 1. By sketching the graphs of y equal to 3 e raised to the power x and y equal to 2x minus x on the same diagrams. Show that the equation 3e to the power x plus 2x minus x equal to 0 has a real root. So for this part, you just sketch the graph y equal to 3 multiply e to the power x and y equal to 2x minus x in the same diagrams. So you will find a intersection point for these two graphs. So you can do conclusion 3e to the power x plus 2x minus x equal to 0 has a real root. Then second part, use the Newton-Raphson method with the initial approximation x known equal to 1 to find the root correct to 3 decimal place. Question 2. By sketching suitable graphs, show that the equation e raised to the power of x minus 4x minus 4 equal to 0 has a positive and a negative roots, with x known equal to 2 as the approximation of the root. Find the positive root correct to 3 decimal place using the Newton-Raphson method. Determine a suitable of x known as the approximation of the root. Find the negative root correct to 3 decimal place using Newton-Raphson method.